answer key before we move the problems around. So if I start giving the answer to the wrong problem, please let me know. All right, so the first one, here's our center. It passes through that. So we know our equation starts off like this. Change to red. It's x minus 5 squared plus y plus 1 squared. And if I put this point in here, 8, that gives me 3 squared is 9. And negative 1 would make this equal what? Oh, that's y minus 1.
Yeah, that's what I was.
Sorry. So 18. So that's the equation for that circle. So we plug in the 5 and the negative 2. If I plug in 5, I get 0 squared.
How did you get 18? Oh, you had to
9 plus 9. When you plug in this point, 8, negative 2. So I plug in 5, I get 0 squared plus plug in negative 2, negative 3 squared is 9. And 9 is less than 18, right? So this one would be inside. I mean, point of inside.
Location.
Yep. And it is also obtuse because everything inside is obtuse, right? Okay. The next one, the center is the point 3, negative 4. So I can start it off like this and set it equal to my radius squared. So to get my radius squared, I'm plugging in 6, and I'm plugging in 2, and did you get 45 right here?
Yes.
Okay. So now when I test 7, negative 1, if I plug in 7, I get out 4 squared, which is 16. If I plug in negative 1, I get out 3 squared, which is 9, and this is 25. So how does 25 compare to 45? It's smaller, so this is inside.
Or outside. Inside.
Oh, wait a second. This obtuse acute thing, that only works if I give you the diameter. I'm sorry.
Okay.
We didn't start off with the diameter on that one. So you can't go, because this point is the center, and that's the radius, and we'd have to look at it here.
It's just asking where.
This is not the diameter. We can do that on this one, and this one, and this one.
How does the diameter affect it?
Differently?
Like how does the diameter change whether inside is obtuse or not? Like I thought inside was always obtuse.
If these two and this point happens to be, let's see.
It's all like
We'd have to test it. We only tested yesterday with the diameter. I'll go back and check that. Yesterday we only tested, so these would be the only 3 that we would be looking at here. All right, so the endpoints of our diameter are 5, 1, and 3, negative 1. So our center would be at 4, 0. So did y'all get this for your equation? X minus 4 squared plus y squared equals 2?
yes.
Okay? All right. And so when you plugged in the point, did you get that it would be outside?
Yes. Yes.
Okay, for this one, the center would be at 4, negative 1. So is this the equation you got? X minus 4 squared plus y plus 1 squared. And when you plugged in one of those points, you got out 8. Okay? And so when we plug in 6, 1, did you get that it was 8 equals 8? So this one would be on.
Yes.
Okay, if it's on the circle, we automatically know it is a right triangle. Okay, this one would be x minus 2. No. X minus 3. Squared plus y plus 1 squared. Uh-oh. What does this equal? I don't see mine on my answer sheet. 5. Yeah, I do see it on my answer sheet. And so did you get this one is on also?
Yes.
So it would be right. Now this outside one we could test for acute obtuse or right, couldn't it? Because if it's outside, it could be any of the three. If it's outside between the tangents, it is acute. If it's outside on the tangent, it is right. If it's outside the circle and outside the tangents, then it is obtuse. I don't think I said it clearly. Okay, this one. Did you complete the square on this one? Yeah. Okay, good. And when you completed the square on this one, did you get x minus 1 squared plus y minus 3 squared? Nope, I'm writing down the same equation as the last one. Yep, equals 25. No, equals 5. Okay, and this one is outside? Okay. The next one I made up. So I ought to know the equation. X plus 4 squared plus y minus 5 squared is equal to 169. And did y'all get on? Okay, and the last one. You want to work the last one? No. Me neither. You want me to just give you the answer?
Yes.
Okay, did you get x plus 3 squared plus y minus 1 squared equals 25?
Yes. X minus 3, but I may just... No, I got that.
Okay, so this one is outside. Okay, I got a negative on this problem and still got integer answers. So I thought I was right, but I was wrong. And it was the first time I worked this problem. The second time I worked this problem, I got it right. But the first time I dropped a negative, which is a pain because you don't notice it, unless you get a weird answer, and then it makes you go look. But I still got an integer ordered pair, so I didn't go look. Yes, ma'am.
For like the diameter endpoints and the through points on the circle, I like graphed them.
To find.
I like graphed like the diameter and stuff, and then I like drew the circle, and then I did the point, and I saw if it was like where.
So you did it all graphically?
Yeah.
Okay. Do you know how to do it algebraically?
Yeah.
Can you do it? Okay. Okay. As long as you can show both, you're good. All right. Any questions about those? Yes.
For D, would you find the midpoint of that diameter and plug it into the equation?
Yep. You find the midpoint on D, and that gives you the midpoint was 4, -1.
Yes. Okay. Never mind. I'm just now looking at my work and seeing how I got wrong.
Okay.
I just added incorrectly.
Your Grace?
On H, what did you get when you plugged in 3, 2?
What did I get when I plugged in 3, 2? I got out 36 plus 1 is greater than 25.
Wait, but never mind.
So it's outside. Okay. Any other questions? All right. Y'all are going to sleep, so we're going to move on with today's lesson. All right. So today we're going to talk about systems of nonlinear equations. So let's do big picture idea first. We're going to look at lines, parabolas, and circles. Line. That's not a bad looking parabola.
Ms. Wilby, is that our schedule for today that's on the board?
No, it's not. Your schedule for the day is right here.
Can I take a picture of it?
Sure.
When does this
When does this class end?
123.
There we go. All right. So if we had a system that involved a line or parabola, how many solutions are possible?
2.
Okay. Well, right now, how many solutions are there on this graph? 0. So the possible solutions between a line and a parabola, we could have 0 solutions. No solutions. Or is it possible for it to touch in one point?
Yes.
It is, but I'm having a hard time making it. There we go. Touch in one point. What do we call it when a line touches? Tangent. If it's tangent, touch the parabola in one point. So one solution, or there could be 2. So the possible number of solutions are 0, 1, or 2. Make sense?
No.
No?
I'm sorry, I'm already confused.
The number of solutions is the same as how many times the figures intersect.
How many times the line and the parabola?
Uh-huh.
I have a question. For the one with 2 solutions, what type of line would that be?
Any line. See? I just drew a diagonal one.
Is there like a certain
Huh?
Is there like called a secant or something?
If it passes through a circle twice, we would call it a secant.
Oh, okay.
Yeah, secant line. Okay, now let's see if we had a line and a circle. We could have, currently, how many solutions are there between the line and the circle?
0.
0. Or what if the line was tangent to the circle? 1. Or if the line crossed through the circle, there would be 2. Can there be any more?
Yeah.
Okay? Let's do, and I didn't orient my parabola a correct way, so let's see if I can do it again.
Close enough.
You think so?
Depends on what you're trying to do.
Roland would like to come in. You're a little early.
Oh, yeah.
Roland.
Why are you here?
2 periods early or something like that.
Why are you here?
Huh?
I need math homework. I'm checking out.
You don't.
It is out of your workbook, and you can check the video.
Okay.
Have a great weekend.
Wow.
Bye, Roland.
Bye, Roland. Bye.
Brian Buck. Agree. Agree.
Wow.
Okay, parabola and a parabola. How many solutions?
0.
0.
Wait, okay.
1.
How many solutions? 1. How many solutions?
2.
2. How many solutions?
3.
3.
All right. How many solutions? 4. So a parabola.
Can you have like
Perhaps squared.
actually if they were
Ooh, I like that. Could be from 0. Yep. 2, 4. All right. What about a parabola and a circle? You think about it, and then I'll show it.
180.
Wouldn't that be cool?
Yeah. Wait,
I mean,
no.
if it
It
curves
could.
right, it could be 180.
It could be 180.
If it curves right.
No.
It wouldn't be a parabola.
It's
Be a half circle.
I feel like doesn't go straight around.
Oh yeah, it could never be 180 because that would
It's
be
the
the
same
parabola
thing.
line
Yeah,
straight
it's
out parallel.
0, 1, 2, 3. Oh, hold on. Let me stretch it.
Vertical stretch.
4. Vertical stretch. Very good. So a circle and a parabola. Could have between 0 and 4. What about a circle and a circle?
Infinite.
0 to 360.
It's infinite. Because
4.
if you put them on top of each other.
That's
Just
only.
kidding. You could do that with parabola too, so never mind.
There could be 0. There could be
1.
1.
Or 2.
There could be 2.
If it's bigger. No, there
If
would
it's
be
a
two.
circle.
One or two.
360.
0, 1 or 2.
Infinite.
0,
I guess if they were the exact same circle, if I gave you a multiple of the equation, I guess it could be infinitely many.
Yes.
You could
Ah.
do that with parabola too.
I guess I could if I gave you the exact same parabola. All right, so 2 circles, 0, 1, 2,
3.
infinite if it's the exact same equation, but just a multiple.
3.
Okay. How?
It'd be an oval.
Even if it was an oval, it couldn't have. Yeah,
Okay.
And when we study the other conics, when we look at the ellipse and the hyperbola, then those would be options. It would be 3.
If this starts bigger, couldn't you have 3?
If the circle is bigger,
And it would just go inside of it.
it would just go either completely inside or, what's our other choice? It'd be the exact same circle. But I can't make it hit 3. All right. We're going to do some examples that are in your book, but your book doesn't give you much room. But if you'd like to work in your workbook, we're going to do page 379. We're going to use some of these as examples today. It's fine. Take some notes. Okay, so we're on page 379, but there's truly not much room in your book, so I don't know that I'd use it anyway. And we're going to start with number 1. F of x equals x squared minus 2. And g of x equals negative 2. Now, we have these 2 equations. One of them is what? The top f of x is a parabola, and g of x is a line. So we can have either 0, 1, or 2 solutions, right? So, is f of x the same as if I did y?
Yes.
And g of x, could I write it as y? So, without graphing this, what could I do to determine the number of solutions? I could use substitution and treat it as a system, because when I solve a system, it gives me the intersections of the 2 graphs. So all I would have to do in this case is use substitution, plug in the negative 2 for y, and solve for x. Do we all see that x equals 0? Yes, x does equal 0. Now, how would we find y? We could plug back in.
It already says that it's negative 2.
Thank you, Brian. It already says that y is negative 2. So we know this one only has one solution, and the solution occurs at the point 0, negative 2. So if we graphed it, we would have, thank you, negative 2. We would have this parabola, which we ought to be able to graph in our sleep now.
That'd be kind of hard.
And we'd have this line. Oh, so
That's 2 points.
far off.
Factors are actually
And we should see that they are touching at that one point, which means the parabola and line are tangent. The line is tangent to the parabola at the point 0, negative 2. And that's our one intersection. Yes, sir?
Can a line be tangent to a line?
No. Because tangent means to touch in only one point, and that is not possible
Well, if
with
you
a
went
line.
through it, wouldn't it be only touching at one point?
Ooh.
But isn't tangent
It wouldn't intersect. Let me research the definition a little more. But no, we don't say lines are tangent when they touch at one point. So I'm not giving you a great definition of tangency. Okay. Let's take a look at number 2. We have y equals x minus 3 squared and y equals x. So if we wanted to find the solution to this, would we use substitution again? So we'd get x equals x minus 3 squared. So x equals x squared minus 6x plus 9.
Where did you get the
Is it over?
That's B lunch.
That's an 8 o'clock.
I'm not used to this in this class. This is
Okay, I know. The problem is we're gonna all want to go back to lunch when the class is over.
Hungry again.
Okay, so when we set it equal to 0, we have now created something that is not factorable.
Wait, you can just take the x out?
Why?
You subtracted it from the other, both sides.
No, I didn't even see you do that.
So I know it won't factor. What are my options, guys? Completing the square or quadratic formula. I'm nay-naying completing the square because that middle term is odd.
Formula.
Odd quadratic formula.
Negative
Negative b plus or minus square root plus or minus square root b squared minus 4ac
B squared minus 4ac.
all over 2a.
All over 2a.
All right, so we get 7 plus or minus the square root of 13 all over 2. Okay, give me the decimal equivalencies for those. Nearest tenth is fine.
What that is? Emergency calculator. Oh no. Emergency. No. Okay,
Number A and number B.
13. Number
A and number B. That's awesome.
Plus that. We write it down. 5.3. What? 5.
5.30277.
Yes, 5.3 is one of them.
Give me 8.
Or.
Okay, so if the x is 5.3, what is the y? 5.3, because x equals y.
Or 1.7.
And then 1.7.
Negative 1.69.
Negative 1.7?
No, it's just positive.
Okay, positive 1.7. Okay, so these are my two intersections. Now, if I graphed it, would it show that they intersect in two spots?
Yeah.
It should.
We just did it mathematically.
I just did it mathematically, and so if I graphed it, it should show the same thing. So we'd go over here to x plus 3. We would sketch in the parabola.
Is this like a new problem, the 5.3 and the 1.7?
We would draw in the line, and we should see that it intersects in two places. Any questions?
Is the 5.3 and the 1.7 like a new problem, or is that still the same?
That's when you simplify this.
Oh,
When
so
you do
we
7
get the-
plus root 13 divided by 2, you get the 5.3. And when you do 7 minus the square root of 13 divided by 2, you get 1.7.
Because it's plus or minus. So it's
Plus or minus. So you got the plus.
From right here,
But I don't have
it's shifted right 3.
Okay.
Okay. Any questions about number 2? All right, let's look at number 3 then. Not that I ever would have done the first two graphically. I probably would not have done the first two graphically, but this third one, there's no way I'd do this one graphically. This is not in vertex form. It'd be a little harder to graph. So I would definitely choose to do this one algebraically, even if given a choice. So we're going to use substitution. We're going to set it equal to 0. I'm going to move this stuff over here, all this stuff. So set it equal to 0, and that way it makes that positive. Okay, did you guys get the same thing I did?
Yes. After I copied it off the floor, I did.
Okay. Once again, it does not factor. I got that 3.5 right there in the middle, and I can tell my only factors of 2 are 2 and 1, so it's not going to factor. I won't waste my time trying, and I'll automatically go to quadratic formula. So I do negative b plus Plus or minus.
Negative 3.5x is what it is.
Yeah.
'Cause you
Oh.
add the 1/2.
And -2. Yeah. Yeah.
Okay, guys, I said I'm moving all this stuff over here. So when I move that over here, it becomes positive, positive, positive. That's fine. You can move all your stuff over there, but I don't like a negative leading coefficient. If you're good and you never drop negatives, go for it. But see, I know I'm a negative dropper. I have to be very careful not to lose a negative along the way. So the less negatives I have to trouble me, the better it is for me. Some of you maybe have very good attention to detail. Something's going on over there, but I'm ignoring it because I'm pretty sure if you ignore it, it'll go away. All right, so now let's do b squared. 12.25. I showed you my shortcut for squaring numbers that end in 5, right?
No.
Oh, shame on me. All right, let's look at it real quick. 5 squared, 25. 15 squared, 225. 25 squared, 625. 35 squared,
Oh, jeez.
1225.
I don't see no relation.
45 squared,
Oh my lord, I love
2025. 55 squared. Oh, hold on.
that. Is my life makes sense.
And then that's
30.
And the next one, 4.
Okay.
4, 2, 2, 5.
4, yes. Because
I got it.
the 5 gives me the 25. And then you take this times a digit higher than it. So 1 times 2 is 2. 2 times 3 is 6. 3 times 4 is 12. 4 times 5 is 20. 5 times 6 is 30. So 65 squared would be 6 times 7 is 42. 25. Did y'all know that?
Wait, no, what? Do that again.
All right.
Oh, I totally get it. Oh my
All
god.
right. What's 7 times 8?
56.
56. 25.
You multiply everything by 8.
Oh my
Wait,
god.
7
no.
times. Why would 7 times
First number.
7?
So like 15, you take the 1.
When you multiply a decimal, it's the same as the other thing, just with the decimal.
So
I have no idea what you just said.
So
And
like,
that's your
if
first
I
number
was
and
to,
2 times
if I was to square 0.5, it's 0.25. So it's like 5 squared is the same as 0.25
Yeah.
squared. Just,
Okay. So that's my shortcut for squaring numbers that end in 5.
okay, yeah.
Your shortcut for 6.
That makes sense.
I share all the shortcuts I've figured. But I can only figure out stuff by staring at numbers. And there's usually a better way.
I like staring.
Nothing better than staring at them.
Sometimes it's fun. Alright, I'm stopping. Why am I not going to do anything else?
Because that is a lot of numbers.
The numbers
Nope.
are weird.
I'm done.
Because my discriminant is negative. Thank you very much. My discriminant is negative, and what does that tell me about the number of real solutions? There are no real solutions. There are no intersections. There are 0 intersection points. Right, Brian?
Yes, ma'am.
You missed the whole thing. What we just talked about, Brian, was the discriminant was negative.
Yeah.
Therefore, we can stop and not do anything else because now we know there's no intersections. We good? Excellent.
Yay.
Okay. I want you to try number 6.
Can you write that?
You will need your workbook on Monday. You must bring your workbook to class Monday.
You try number 6.
Really not.
No.
Can I help you?
It's been like big numbers. I don't like it.
Turns out. Is that the one that turns out pretty? Oh, that one turns out really pretty.
So 1.
Turns out nice.
Wait, what does?
Number 6.
Wait.
Didn't it turn out pretty?
Oh, I didn't see.
I got the 1/2, plugged it right in there, and got 13 1/2.
That's actually what I got.
Awesome. I didn't because I looked at this, I saw a common factor of 4. So I divided both sides completely by 4, and I got this. And then I looked at it, and I went, ooh, perfect square trinomial. I don't have to use quadratic formula. I can factor.
Miss Willoughby, how come if you use a quadratic formula on this one, you get 0? What happened to
If you use quadratic formula, you should get 0.5.
You get
No.
0 as the discriminant.
That's a negative.
You get 0 for the discriminant.
Well, a discriminant of 0 tells you there are how many solutions? 1. How many solutions did I get? 1. Good job. The discriminant should be 0. Can't factor?
How does that turn out nice?
How did it turn out nice?
Yeah, not really 1/2. I don't like fractions, so that's not really nice.
How come you got
1/2?
Oh, you have to plug it back in?
It is a fraction.
Yes, it's a very complicated fraction. It's fun.
So Johanna, what you do is you take 1, and then you take like part of 1, so that 1 part.
Okay, take a look at number 7, guys. Those of you that have your textbooks, on page 379. Those of you that don't, look up here at mine.
Textbooks or
Workbooks.
So see that.
Okay, number 7 is right here.
Over
2
here.
points.
What page is it? Oh, this one.
379, right here. How many intersections?
2.
2. Can you write down the ordered pairs for them?
Yeah.
Yes. The next one. How many intersections?
1.
1. It is tangent. Could you write down the ordered pair? Yes. Now, in the work I'm leaving you for Monday, there are 2 that they ask you to graph to find the answers. And then the rest of them you're going to solve algebraically. Now, you can always solve it algebraically to check and see if you did it right too. Okay? Any questions about that? So that is lines and parabolas. Now, let's change gears and do circles and lines.
Oh my god. I thought we were done.
Did you really?
Yeah.
Okay. Flip over to page 404. We are recording. I had several people in the first period and several that were absent right now. Okay.
Do you ever record in first period?
No, because I don't have time to. When you record it, you have to have time to allow the computer to sync the audio and the video before you can use the recording again. And then it takes a good amount of time to upload to my YouTube from our school because we have so much on our server. So I usually upload during my planning period. And then I upload again at the end of the day. Because I don't have time when another class comes in. Okay.
First period you might not feel very
Alright, because several of you don't have your workbooks, I'm going to open up my workbook online.
Miss Willoughby, I have a quick question for you.
Is it a math question?
It's pertaining to the class.
It's a math class.
We just asked.
Okay, I heard that first period didn't get new seats.
Really?
Really?
Wow.
Is my friend in first period lying to me?
What did she say?
She said she heard that first period did not receive new seats. That's awful.
Wait, did they or did they not?
Maybe. See if I'll have a book when after we go through this, and I might have an opportunity to answer questions. Alright. Alright, so here we go. Circles and lines. Circles and lines. Oh, y'all can do this. You don't even need me. Try number 10.
Exactly.
Literally, you do not need me.
Don't even need to
You try. Woo, this is easy. Page 404.
It's 2 4s and 1 number.
It's gonna like that.
So did they get received or not? I'm confused. Is that y squared? Yeah, that's like
That is y squared.
Pardon me.
It's a carrot. Why is there a carrot?
The carrot can be used to. It's a editing issue. They didn't catch it. But if you were to send me an email asking me about a question and I had to send it back to you, I would have to use the caret key to know what was exponential after that.
Superscripts.
Yeah.
Wait, can't you do that in email though?
Not in mine.
Oh, okay.
She's not fancy.
Mm-mm.
I don't do that.
Don't even need to do that.
Oh, we do it by graphs.
Worst.
That's a fantastic. Great. Okay. Much better than mine.
I'm lost.
So that's a circle.
Is this material from the quiz?
No.
Graphing a circle and graphing a line? Yes, that's previously learned material. The center is at 2, 0. The radius is 2, so we go up 2, down 2, left 2, right 2. Sketch the circle. Then we sketch in the line.
What you do is graph it?
Yeah, it says solve
Okay,
each
when it's
equation
like
by
you
graphing.
add, is there the invisible one? So it's like goes down.
Yeah.
All right, so how many intersection points, guys?
2.
2, so my solutions are 0, 0, and 2, negative 2. Now, could we also solve it algebraically?
Yes.
Sure, let's give it a shot and make sure we get the same answer. So, had we not had graph paper, which some of us didn't and we didn't have our book, what would we do? We would get 2x squared minus 4x equals 0.
Wait, how would what? I don't think I understand.
Okay, so since y equals negative x, I would plug negative x in for y. Does that make sense?
That does make sense.
So that's where this came from. I square negative x and it becomes positive x squared. That also makes sense. I combine like terms because that makes sense. And then what happens to this and this?
It makes sense.
They cancel. Now, do you see I have a quadratic that is easily factorable because it has a greatest common factor of 2x. So, x either equals 0 or x equals 2. And we plug those in to our linear function, and we get 0 paired with 0 and 2 paired with negative 2.
Wait, how'd you get 0 and x equals 0 and 2? Could you go through that real quick one time? Because I'm writing it down and 300 people are talking when you're talking, Miss Willoughby. Like, not like in the class, but like your voice is going to
So in the world, like, you're people talk.
It's going so fast, I can't harness everything.
All right, be really quiet and concentrate. Everybody in your head, don't even think of anything other than math right now. So we have 2x squared minus 4x, which is a quadratic. Factoring is the easiest way to solve this quadratic because it has a common factor of 2x that we pull out. And that leaves us with x minus 2. So either this is set equal to 0, which is where the 0 comes from, or this is set equal to 0, which is where the 2 comes
So
from.
it's almost like there's like 2x and x minus 2 are like two separate little things. So if you plug in 0 for x,
Yeah,
you want
'cause
to get
this-
0.
The only way that product can be 0 is if one of the factors is 0. Okay,
So it's almost like you have like two little like binomials, but it's like okay. So that's the.
all right, are we good? Okay. All right, you try number 11.
I already did that.
Just do it graphically, and then we'll do some algebraically.
Yeah, I don't like algebra. That's hard things are not fun.
You would if you're going to do it algebraically. If you're going to do it graphically, you just sketch it and look at where it crosses. Yes.
I'm sorry, I thought you said do it out.
That'd be fun. We'll do that one algebraically after we do it graphically.
Oh, but that's not.
I got it.
You got it, but then
She got it, but she's stuck.
you.
All right, should look like that. We can easily see the points 2, 1, and the point 1, negative 2. Okay, so negative 1, negative 2. All right, so if we take this and we do it algebraically, we'd substitute that in for y. So we'd get x plus 1 squared, which didn't change, plus x minus 1 squared equals 9. Because we plugged in an x minus 1 right here where y was.
So 2x squared plus 5.
So this is actually x minus 2 now.
Oh, it's better.
So now we get x squared plus 2x plus 1 plus x squared minus 4x plus 4 minus 9 equals 0. So we get 2x squares minus 6x and then minus 4. So we divide by 2. And we factor. Wait a second.
Wait, how'd you get
This is not right. This is not minus 6. I'm like, it doesn't factor that way. This is minus 2. Okay, so we get x equals 2 or negative 1. And what were our x's? 2 and negative 1. So we could also do it algebraically. All right, questions? Okay, let's look at some more of these that we will do algebraically. All right, algebraically, let's take a look at number 13. Very simple. Since x squared plus y squared equals 10 and y equals negative 3x, what can we do? Substitute in for y. So we get x squared plus negative 3x squared equals 10. So 10x squared equals 10.
What?
Oh,
Oh my gosh.
y'all are
I
killing
see it.
me.
Never mind.
Y'all are killing me. Are we okay now? All right, did you get plus or minus 1?
You already got the answer.
You do that just by plugging it into.
Okay, so we plug in positive 1, we get out negative 3. We plug in negative 1, we get out positive 3. Okay, you can try either 14 or which one? Let's agree. 14. You try 14. Probably. Your answer is going to be in radical form.
Awesome. Thank you.
Okay, if you're watching this video, I think you've seen enough to understand what's going on. And you can look at the notes for more examples.